well, it is a bit of boom. The AA creates historic occasions, and this is one of them. Frei Otto joins his great predecessors, Frank Lloyd Wright, who's lectured here, and Le Corbusier, and is addressing us today on fundamental architectural and philosophical ideas. However, there is something quite different and special in Frei's relationship with the AA that the others didn't have. He was part of the team that created the buildings at Hooke Park, which now belong to the AA. When I say part of the team, he's joined by other members of the team, his daughter, Christina, who's sitting, his wife, of course, who's a great supporter, and myself, who was the architect with Frei. There were other members of the team, and the late Ted Happold, the great engineer, and Michael Dixon of Happold's. Now, Christina will be giving workshops at Hooke on Friday and Saturday of this week. She gives the MIDA workshops. And it is wonderful that the whole family is here. Thank you for coming. Moisen is devastated that he can't be here tonight to hear you speak, Frei, and share your thoughts. He asked me to say on his behalf that he is in Geneva working on the Aga Khan jury. However, as many of you know, Hooke is very, very close to his heart, and he hopes you, Frei, and Christina will participate with us to create an extraordinary place in the future. So, we welcome you here tonight, Frei Otto. Your architecture, which spans from the buildings for the Munich Olympics to the project for the Stuttgart railway station today, we salute your way of thinking, which has affected our recent past and is central to our future. Frei Otto.
Could we shut it up?
The light.
Mm. My dear friends in London, ladies and gentlemen, it is, I think, the fourth or fifth time that I speak here on the school, and always my heart has something to do with the AA. I really do not know how I should make this evening, but I will try it, and I hope that my slides, you could see them in this special room. It is, for me, I have always to wait some 5 minutes to get back to the English language. It's not my mother language. And I feel I have a terrible accent, but please pardon me. I'm an architect, not an engineer, as many things, but I always was interested in a good relationship between architects and engineers, and I think it's very, very important. Our profession is driving apart, and especially handscrafting and all these things are now in a problematic situation. some people think that they only could sit behind the computer and making design. I know that design is done in our brain, and the sketch is the first thing which is coming out, and that what we are thinking in our brain, how we can bring it into nature is one point, but also how we can study the nature so that we can be a part of her. And I think that the architects should be helpers for man, that man can live on the surface of earth. They must help to that catastrophe cannot kill people. That's quite simple, but it's very much necessary, because until now we have these big catastrophes of non-living nature killing us, but the biggest enemy of building is man. And I have seen in the last wars cities burning, and that is not a nice view. And these are men destroying houses, destroying cities. And when we started to rebuild our country, other countries, Middle Europe, we always were thinking that there is no building which can be stable for centuries or longer. Buildings must always change to be perfect. And also people should die when their time is over, but die with excellency. But some of buildings should be protected because they should show what people has been done and should be a help that man can go into the future. All these I will try to tell you, and let's go ahead. Could I have my first picture? Well, it was after my last lecture here. We did sit together in a restaurant, and so the idea was born that an object on which we worked together, Richard Burton, Ted Happold, and myself, and many others from our teams, for John Makepeace to create a school to use wood. And it was Richard, I think it was you, to make this drawing on the left side. It's a little bit out of focus, please pardon it. And on the right side is one of our first model to make a workshop, a central building, in some houses for people which are living there. Next picture, please. And some models which we studied on the left side for the central building, just a tent out of wood, because we said that we could use those wet trees. The forest was planted, I think, 56, and the trees did grow to a height of between 12 and 15 meters, very thin, and we tried to use and to make buildings out of wet wood, where the wood should be drying in the building as an experiment, because we had not the time to wait that these trees could be dry by themselves. Next pictures. This is the so-called master house. it is hanging trees from the ridge. On the right side, we studied the model on the side. If you have a little model, you should go to the side and to look where the best side it is. The side was beautiful. We remember the day when it was the first time on the side. The ground was blue, from blue bells. It was really beautiful. Next picture. This is now the ready building. How you call it, master house, or I don't know what is the official name now of the house.
I don't think there's anything official.
There's no official name, but some of you are going tomorrow to Hooke Park and will see it. I have not seen it now for many years. I hope it's still existing. Next picture, please. And for the workshop, we made models out of very thin stainless or brass bars, studying the shape. Later on, I used once more these experiments for the World's Fair in Hanover last year. There was a young Japanese architect. He's now pretty much known, Shigeru Ban, and we made the building together. But before we made Hooke Park, next picture please. And it was like this. You see the very thin members. We studied, of course, how they could be arches on the right side. We pulled them down and to make a grid shell out of wooden arches, bending it just by power. Next picture. And this is then the workshop building. We covered it with a tensile membrane out of polyester and with PVC coated. Next picture. And I will tell a little bit about modeling and how to bring out of models buildings. These tests I made 1958 with my class at Washington University in St. Louis, USA, showing a rubber membrane loaded with nails, and later on converted and to make it as a shell under compression. We call all these structures shells without bending. They are related to old vaults which were invented long before the Romans. Next picture. My largest building was the so-called Multihalle in Mannheim, done together with the architect Mutschler and Langner in Germany. The engineers had been of Arab and Partners in the time where Ted Happold was the leader of the so-called Structure 3, the kind of a fire police for problematic projects. But it happened that Old of Arab asked me, if you will do a building like this, I would like to do it. And it happened that the German engineer, which we had on site and we should use him, said, it is too much for me. I have not the courage to build this building. And I think it is a problematic building because the span is more than 80 meters and the wood is very thin. There are lattices of long grain wood the hemlock pine of Canada we used, and the lattices are 47 to 40 millimeters, not centimeters. And I said we could build a building just with the lattice of the roof without the structures underneath. So we did it. And we are happy the building is standing still. It was planned only for one summer. It's now a protected building. Next picture. And we learned very much. It was an exhibition, so-called, I can't translate it, Gesamtkunstwerk. A total art piece was the name of the exhibition by a Swiss art director. And I was asked to reconstruct the model which Anthony Gaudi built in the 20s of last century, but the model was destroyed 1936 in the Civil War of Spain and completely lost. Nothing remained of this model, but only 21 photographs did exist. And using the method of stereoscopic reconstructing a building, we did the model of Gaudi once more. And now we have not only 21 photographs, but many more. And we even could see more, as everyone did know. You see the model is on the left side. And you see in a mirror the standing object. The object is the chapel in the Park Güell in Barcelona. And on the right side, it is a photograph inside the model, and with some fantasy you will see how the chapel in Güell would have been looked if Gaudi would have built it. The model stands now in the basement in the Museum of Gaudi in the Sagrada Familia. Of course, I did not the whole thing with my own hands. It was specially done with the Dutch group around Jan Mollema and Jos Tomlo. Jos Tomlo is now professor in East Germany, and and Jan Mollema in, I think, in Rotterdam. Next picture. Of course, if you have any questions to these things, please ask, that we could start a little bit discussion. I would be happy if you could do it, so I know. Our largest project on which we are working in my office since 6 years, the architect is Christoph Ingenhofen. He was invited to the competition for the station in Stuttgart. The station in Stuttgart was built in the 20s by Paul Bonatz. He was a hero of the Stuttgart school. And the trains are on the upper level. It's a so-called end station. And this station should be turned in a, I don't have the English word, going through station, which is in a right angle. And on the right side you see our design for the competition. to be underneath 12 meters under the ground and to have open holes which are supported by columns. And I offered to Christoph Ingenhofen, firstly the engineer, of course, the Buro Happold, and especially involved is Michael Dixon and now also Ian Little, and joined them together with Fritz Leonhardt, the very well-known German engineer. Maybe you know he invented the concrete television towers and built many suspension bridges. So, but next picture. But how to solve the question? I give some sketches because the railroad station is only between 9 and 12 meters underground. It is 430 meters long, nearly 100 meters wide, and had only a room between the surface of earth and streets of these 9 to 12 meters. Very important is now how thick you could make the ceiling, which should be planted, because the room is going away. And so I remember, if you will make a big concrete plate, it should be there nearly 2 meters thick. If you put your column so far away, we decided that it is necessary that the columns are about 34 meters away. And it's nothing. It should be a very, very flat space. It would be the largest space of the city of Stuttgart. Stuttgart has about 600,000 inhabitants, but all around are about 2 million in the so-called outer region. And I remembered, and the question is always how good are now the knowledge of the engineers. And we know that to calculate reinforced concrete, it is somewhat, I will not say superficial, it is very good for normal buildings of small span. But for a longer span, there are problems, because normal concrete always will break. You can, of course, pre-tension it, but pre-tensioning, you can then bring the 2 meters down to maybe 1.50 meters, but not more. And the calculation shows you, and you are calculating with the elastic theory, but there is another way of calculating it. I show you on the left picture. If you put all concrete away, which is not in compression, then you will have a two-dimensional thin shell in the concrete. And you could also calculate it in a way which is shown on the left side. But still, then you would have the tension members 2 meters underneath, and we also could not use these tension members. On the right-hand sketch, you see those many possibilities which we had to solve this incredible question, and just to dig a valley. The valley will be filled with groundwater in a few minutes, because the railroad is just crossing a little stream. There is just a stream which is going out of Stuttgart. Stuttgart is a huge funnel, and there are big water sometimes in rainstorms. But so the first upper line was what we did at first to make this valley and to hang over in the valley a tension structure. But then we started also, because the client wanted a section which is under the second sketch there. But we studied then all different ways, and we are still studying, because it may need 2 further years before the building will be started, and it will be not been ready before nearly 1920. It's a very, very difficult question, and I do not know if I would see the building. Next picture. And to show for the first step, of course, you always are using things which you have done. So I was thinking for the railroad station Stuttgart to use a cable net, which I have done for this building. Next picture. It is the Montreal Pavilion. Or for the Olympics, we have had a cable net. And we studied also to use the cable net and to plant it. Next picture. And this solution was coming out at the beginning, but we have had only 3 months' time for the competition. You see the cable net, and this would be then the structure. Underneath of the point will be a mast. And I tried also to reduce the railroad station. That's for 6 lanes, but we have to build it now with 8 lanes. Next picture. Then we studied the so-called hydrostatic shell. In the ground, and you know it from the London subways, that's the best shape of a tunnel in groundwater especially, and we are here in groundwater, is the shape of a tube or a fire hose which is filled with water. This is the so-called water shape, and you can reverse this into a shell and you are getting out shapes like this. Of course, they are difficult to calculate. Next picture. Next, please. We have done it. We have been invited by Italian friends and architects for a competition for the railroad station in Florence. And we offered such a hydrostatic shell, but this is much lower. It is about 24 meters below the city of Florence. The tunnels are driven just underneath of the city. But it is possible now to calculate it, to do models and to calculate it, and also the groundwater flow is above the tunnel, under between gravel, and we should not destroy it, because the plans of the Italian was just to make a big caisson, and they stopped all groundwater. It will get an ecological problem. Next picture. But once more back to Stuttgart. If we have to solve this problem with a kind of a shell. We have once more to study what is a shell, what is an arch. And since Hooke, the famous physicist and mathematician, we know that we can invert a hanging chain into a self-standing arch, or a grid of chains into a standing shell. As I have shown you with the Nervi model, Nervi used this method just 100 years ago, but before was a German architect for the city of Karlsruhe and many others, but no one has proved, is this idea, I take a chain and let them stand, and the standing arch in the best shape is exactly like the hanging chain. So I use those methods which I have had at my Institute of Lightweight Structures in Stuttgart, and we made tests, built it exactly as arch, even also under load on the right side. I could prove that this is correct, but we could not 100% exactly tell that Hooke and Newton have had a right thing. You know a little bit that the structure of St. Paul's Cathedral here in London was following this way, and there are 3 domes above each other, and the really one which is taking the load is the cone shell out of stones in St. Paul's. Next picture. When we made these studies, automatically we did come also to us a shape, and here we invented an S-curved arch for maybe to go over the water. Very often a street will move from one side of its stream to another one, and automatically you need an arch which is in floor plan an S-curve. And also we made the design for a bridge which has a floor plan which is more like an U. Next picture. And in this way, to make a shell without bending, and a shell without bending is always a volt, especially out of concrete. It starts to break and it's out of stone. And the oldest method to make it is a so-called cross volt, which is standing. This little model is standing without collapsing, but it's out of wooden stones. It doesn't matter if you make the model out of wood or stone or lead. You can use all materials, because to get the shape, the material is, you have the material completely free. Only when the material is too flexible, then it could collapse a little bit earlier. On the right side, this is the oldest method to make roofs or vaults with stone, the so-called laid, the free laid dome. It is even not necessary that these stones can be together. The friction is enough. I was many years ago on the Shetland Islands, and I discovered that about 2,000 or 3,000 years before Christ, these kind of domes had been built, it means 5,000 years ago, in the Shetlands. They are now broken, but the basement is still existing. Very interesting how early people in your country has started to make these buildings. Next picture. But we are still on the railroad station Stuttgart. How to do it? To combine an air hole that air and light can come into this huge space. Believe what are 100 meters to 430 meters. And we made this model on the left side. The model was hanging out of a very thin woven material like a rail, and then powdered with plaster, and then in a dust of water, and the plaster will get hard, and this model was coming out. Always we try not too much to manipulate, just to discover those shapes which will come out by themselves. It was the model where we then, in the team of architects and engineers, decide we will go this way for the competition. Next picture. But how to put the columns should be used like the model. Of course, a model we just take a square grid. We are a society of right angles, a Cartesian society, right angle, right angle. But if you want to test how the columns should be stand so that every column is taking the best space, we invented a method which is this one. We take little needles, make them magnetic, put a little point of styrofoam on there, and if the magnetic forces are parallel so that always one pole is above and the other one below, then they have the tendency to swim apart. And if you have a closed frame in water, they fill this frame in the best possible way. One experiment of the right side, the big dot in the middle is always the needle, and you see they have a kind of triangular grid. And the land which they, or the water what they are using are then more hexagon. And we invent another method to make to bring a little method in that other pieces are joining together. And if you have a very thin styrofoam and you pull it on water, then they start to pull together, just vice versa than the magnetic needles. And with this play you could study cities and how man is covering earth, or the earth which are higher animals are using, like eagles or foxes. And we made these studies also. I developed it much earlier, and did then change the position of the columns. Next picture. And we made then the columns in hexagon grid. This is a calculation on the left side, a so-called minimal surface calculation by friends of mine, which have been my students, Bodo Rasch in Stuttgart and Jürgen Bradac, and the inventor of this method of calculation is Eberhard Hauck. It's called the LISA. And you are getting out the same thing as on the right side. On the right side is a soap bubble. And in the soap bubble, if you put a little hair inside and put the soap and destroy the soap bubble in the middle, then you get a exact round circle. But if you pull on one point in the circle, you get a shape like this. I use the shape for many buildings. I have shown you our Montreal Pavilion, and also for the Olympics in Munich, also for my institute. You get a wonderful curve. This curve, which you see on the right side, around the hole, is a peculiar line. It is a line in space with only one radius of curvature. Has exactly only one radius of curvature, but not a circle, but the line starts here, is going around, and is coming back, and to the point where the forces are meeting, it is in space a curve with one curvature. You know another famous one, it's a spiral line. Maybe you could use it as a spiral stair. Next picture. And we use then this line, and you see how the holes are now put in order, but a little bit disturbed because they should stand in the middle between the rails, so that people can good see it. And from a certain line it looks nearly like a circle, but it is a circle in space. Next picture. And this was the answer, and with this model we did win the competition. And we are of course happy, but then the big work started. And so we are now, we will not believe it, 6 years on work. Next picture. This was a railroad station, Stuttgart. Now, it is just 5 weeks ago, we could open a bridge, 2 new bridges, which we built, and I show you a little bit the history. It's a footwalk bridge, 120 meters long, but the story was always you could use straight bars to solve some structural problems. I use them for a so-called hump tent, which we built in 1957 with a great tent maker, and Peter Strohmeyer, a tent which is curved like this with straight bars to connect the canvas with a pole. But be careful in the point when we wanted to erect the tent, it is just did collapse, because it did turn this point, and so we had to make the little funnel underneath. The collapse was not a problem. The tent was only 24 meters spanning, and very, very light, and my friend Ewald Bubner did erect it and nothing happened. But then for another building on the right side, I had a grant from the German government, the Minister for Research, to develop a new runway or a new Fahrweg in German, a way for the German magnetic railway. I think you are calling it a maglev. And this should be better and also should have better aesthetics. I did this work together with the team of Ted Happold. He by himself was very much interested in this type of structure. One of the results is the right one, but we made several proposals. Of course, it was going not out of the Ministry of Research, and so maybe the ministers for the railways did never know what we did. This is typical in many countries, I think also in yours. And next picture. But the bridge which we opened just is similar. The model is on the left side, and on the right side is the execution. We made a new trial. We did not build the bridge out of steel tubes, but out of steel bars, full bars of 70 millimeter thickness. And the whole bridge is only clamped with a special clamp, only one clamp, but which is turned, and all the bridge is zinc coated. As I said, 130 meters long over a street. You see the street will be enlarged on the right side, it's still small, and over a little stream behind, and in a slope. Next picture. These are details. We developed also the clamp with 4 screws. Next picture, please. It looks on the right side pretty large, but 70 millimeters are really not. It's just like this. The bridge is very, very stiff. Only those bars which are above the walkways, they have a light tendency to swing, but under the footwalking, the bridge is moving nearly nothing. And I wanted that it's only clamped, but the engineers, this time once more, Buro Happold together with Buro Hilbers in Berlin, we all wanted only to be clamped, but then we have had a proof engineer, and the proof engineer should understand also, but sometimes if you don't understand, he was demanding. And so some of the points has been a lash which is velvet, which I don't like. But normally the bridge is only screwed. And next picture. I'm coming now to another method of design, which was also developed out of models, the so-called tree construction. Of course, a living tree and the branches are always in bending. And I don't know why the living tree was invented, because branches in bending needs most of material. But living nature is not invented for a certain goal. When a thing is in living nature, it is then developed and developed. But if you will, but you can use this type of structure when you are, especially when you are put them in compression. The model on the left side I made with my students at Yale University, 1960. It was hanging like the Gaudi model, little not wires, very thin threads, which we bound together and then stiffened with polyester, just make it wet with polyester, and we could help the model in taking an upper plate. We with this type, we made then in the late 70s a large project for Saudi Arabia, especially for the Council of Ministers and the new chamber of the new parliament called Majlis al-Shura, and we have had some good idea. And the models has been done in Germany in my office. The calculation in Stuttgart for the Majlis in a joint venture between OV Arab and Buro Happold. And we have been sorry we could not build it because King Khaled died before. But we used the method then for our second version of the magnetic railway on the right side. And in this time, Norman Foster used this thing a little bit in a little different way, but the method of calculating for the new London airport. Stanford, or yeah. Next picture, and a very peculiar thing. This was the tree structure for the Parliament of Saudi Arabia, which we did not build, but it was published. And now, and now, if you enter Stuttgart, you see our column there by a very well-known German architect and a very well-known German engineer. The only trouble is they did not ask us. But Rolf Gutbrod, before he died, rang me by telephone, said, last not least, we have from the huge project for Saudi Arabia, it was a governmental building, at least a little piece standing. Next picture. But you can use the method also for a very small thing with not real functions. I made a little sculpture for a poet in our village, and is a well-known German poet, always making poems for the nature, and so I have given him this type, a real tree where water drops are coming out, falling in the basin, which is the old fountain of the village. Next picture. Lightweight structures can get lighter and lighter. And the lightest one is the thin membrane, but when you are working with new type of structures on the left membrane, and it was 32 to 28 meters large, and we made the shape in reality like the model and push it with hydraulic power and was getting this shape. We used for the left structure, it was in Berlin 1957, a new material, a polyamide fiber called Perlon, similar to nylon. But what happened, the fiber was not good enough in ultraviolet light, and so the structure did open. It had a so-called tearing. The owner of the restaurant rang me. It is just beside the palace of the German president, just behind the structure stands this in Berlin, and said it was wonderful, it did open. But Peter Strohmeyer, in 14 days I have had a new skin. On the right side it was, I'm a member of the German Academy of Arts Berlin. It is the oldest institution for arts, 300 years old, and for the festification, which was 4 years ago, I made a so-called Academy ship, an air balloon inside lighted and has music in it. I worked very much for the so-called air structures. They have been invented 1970 by an English car engineer named Lanchester, and he has never seen one. But we developed, without knowing this pattern, this early pattern, completely parallel, it in Germany, and at the same time, Walter Bird, we later have been friends in the United States, the so-called air halls. Later on, I think now in the world are about 100,000 air halls, very often used also by from the Russians, because they are very stable, and especially not only in wind but also in snow. Much better as people think, because snow will not let on, it always slides down. Next picture. The Academy ship was a movable structure, also a little tent. And working with movable structures was a big goal for us. We founded with Jona Friedman and with the artist Yves Klein and others, and a little team, 1953, the so-called Development Center for Movable Architecture. L'architecture mobile had a French name. But a typical shape is on the right side. It was a pavilion for Venezuela of Foto Vivas, the architect, once more the engineer Buro Happold, for the fair in Hanover 3 years ago. But on the left side, you will smile, it was my proposal for a crazy competition, Compton Verney, opera. But I did not succeed in your team with my proposal to make an open-air theater where the people and the players could be protected, but if good weather is, it's open, and if bad weather is coming, it can go down with a grid shell and covered with a very thin foil. Next picture. I developed then a large roofs which are close together and pulled down over maybe a theater, or we use them also for swimming pools and other ones. This object is the ruin of Bad Hersfeld, where an open summer theater is. The roof is 40 to 40 meters and covering about 1,800 people. And you see on the right side inside, and the canvas is pulled to the mast. Next picture. There is the canvas just moving for the building which I have just shown. Our largest project was for an Olympic-sized stadium with a tilted mast. I have had built it until now only to 75 to about 60 meters for a swimming pool in Bavaria. But this project, of course, we have not built, and I would not know if I would have the courage to do it. But a French architect used this method for the Olympics in Montreal. As I remember, it was 76. But he built the tower out of concrete, has had problems because the tower, like the tower in Pisa, wanted to fall down. My friend Fritz Leonhardt helped the Canadians then to stabilize it, but he ordered the canvas, an aramid fiber in Germany, but the factory who produced the membrane did not know for what, and it was a problem. Much later on, I think in the early 90s, the roof was installed, but I'm very sorry, it failed twice, one under wind and one under snow. The architect was very proud to make the thing, but he did not want that the inventors really could help him. And the problem in new structures is never the pioneer building, but the second one. The second one is always a problem because people see the pioneer building, all is okay, it stays in the air, and then they think, we make it cheaper, we make it better, and it looks better, and then the problems are coming. So be careful, but still, I think we as architects and engineers, we should go forward. We have to do experiments. Next picture. And the whole other evolution we did, umbrellas. Umbrellas, and the real old umbrella is at least 5,000 years old. The old Egypt has it, and in near Baghdad also they have found some stone where umbrellas are shown. But I made other umbrellas where the water is going inside, and they can then overlap so that the water is not falling on the outside, because if you are overlapping the normal umbrella, I like the normal umbrella. It's one of the most beautiful and wonderful invention of architecture. But the normal umbrellas, always the water is getting inside. And so I made this building on the left side for on the garden exhibition 71 in Cologne, on the other side of the Rhine, just vice versa of the cathedral. On the right side, these are not portable, they are stable, but when they are not used to be collapsed. It was always my idea. So many buildings are standing around, especially big halls, without use. They are used today. An exhibition hall is used maybe 2 or 3 months in a year, and then it's standing only around. And why to have these buildings which are empty? On the right side, these are umbrellas for the Pink Floyd group. In the first test we did here in London on the so-called, there are big halls and they called Olympic or similar one. But this tent was done in Germany because they have been produced in Germany, also with the help once more of Bodo and Jürgen Bradac. And these umbrellas, they have been in the stage and they are covering the stage, the Pink Floyd people. I met them and they have been 3 people. They did study architecture, I don't know, maybe on this school, but then they discovered it is easier to make money with music. And I offered him my design. They looked only 10 minutes on, then they looked to me and said, make it. And I have never seen them later. But we built it for the big tour in the United States, and coming out of the ground, opening when it rains and going back. But the people was getting wet because 10,000 people did listen and send in their big time. But it was a wonderful little structure. The umbrellas are not very big. These umbrellas are about 6 meters in diameter. This one had 17 meters. Next picture. And my Stuttgart friends are using them, especially in Saudi Arabia. I was once invited to make a new city planning proposal for the Hajj. And you must know it's a big problem. 2 million people are in the so-called Mina city for 1 week, and this city has to be okay in this time. Big problems, burning, people's flow, and things like it. There are a few design for the roofs of the big mosque on the left side in Mecca. But I think their best building is the right side. It is a big mosque in Medina. This mosque has 2 courtyards, has many more courtyards. The other courtyards they covered with sliding domes, which can move sideward. But this one is my umbrella, and this umbrella is now 12 years working every day, mostly open at night, so that the courtyard can cool down. During the day is open to reflect most of the light. Next picture. The newest project is just for my city. We have not shown it until now officially to the city. This I will do next week in a lecture, so you are the first one that I show it for the city of Stuttgart. And for the center is the large Schlossplatz, the plaza in front of the castle, where people are gathering together and sometimes getting wet. And so we are offering this type of structures, and the umbrellas has then a diameter in the neighborhood of 35 meters. Coming out of the ground and opening like the left drawing is showing on the right side the open umbrellas in front of the Middle Age Baroque castle. Next picture. Another experiment, it was the critic Peter Blake called this, it may be the only real experiment in housing. It was a question, and it was a building exhibition in Berlin, 85. I was invited to give an example. I said, why shall we not build floors in the air, like an artificial surface of air of the earth, and to allow people to build their own houses with the quality of the self-built own house. The ground was a famous ground. It was where the Catholic Church has their seat in the German, as a nuntius of the Vatican had it, but the city of Berlin bought it and should give it only as a social housing program. It means it has to be built under social housing program. It means the inhabitants should have not much money. Should be only in middle class, but not in upper class. And so I did it. We made in a height of 6 meters a concrete plate, and in the height of 12 meters one. And there are 3 bigger houses where 4 in the basement, 4 in the upper level, and 1 above, so that in every house we have 9 single houses. And some of the single houses, they have been self-built. I know from this man here, he was is a school teacher, has taken 1 year free, without money of course, and built them his own house. And so it happened that every house has been built by the owners. Some has had a private architect, some not. And I had only the duty to be a kind of a helper, that they build peaceful, so that they don't start to fight one against the other. And it was among the trees of this beautiful, but it's in the center of Berlin. It is a kind of building with the quality of the single family house, but it is near the deer garden and the zoological garden, just the center of West Berlin. We built it before the big change in Germany did come with this method. I think it was a big experiment. I think today it was a good experiment. When Ingrid and myself are near the building, as it happened last year, one owner was coming out, has seen us from inside, and then he starts to talk how good it is and how beautiful. Now the houses are costing 3 times more as they have built. They are very happy. Of course, I am not responsible for the facade because I have given the facade free. Everyone should do what he wanted because I am a man who likes that good architecture should grow in freedom. Of course, this is a large project, not my largest in housing, but then I show you my last picture. It's my smallest building. Next picture, only 2 years. It has 11 square meters ground floor, existing out of 3 plates of plexiglass, just in the production size. And the plexiglass is self-supporting, just connected in the middle, in an open joint. Of course, I wanted to close the joint. Of course, Christine did most of this structures, many structures. He has made also the bridge. And the owner the owner is very, very happy with it. And the pavilion is not seen, of course. Also the government doesn't know that it stands in the garden. And you see when rain is coming or condensation, short time you have in the morning condensation, it makes these beautiful structures which are lasting 1 or 2 hours. And the ridge is open, but quite interesting, you see. No rain is going through, it's dry underneath because the water is always going away. Snow doesn't help. It is in our village Wambron where all these things are done. This was my last picture, and I hope, I don't know how you will organize this afternoon, but I would be very happy if you have some questions, and I think you must have some. I think it's now your turn if you...
Or if you want me to come with you. Now, there are a lot of us here, and it must be really buzzing in your heads. You must really want to say, there must be questions, there must be... there, over there.
Right, but you've done so many different typology of building. You've done so many different types of typology of building. Is there any ambition that you've got to do another kind that you haven't done yet?
What you mean with this? Still the thing what I have not done until now.
Yeah, there's still something left.
Oh, there are many. There are many. Just some people wants to make a new building with these things, and I started to write down possibilities to study. Most are studies of non-living nature, and these are physical experiments. I think I know about 200 different methods, and which could be used in architecture, but also in another one. And in the late 50s, 58, of course, when we developed the air structures, also I designed a sketch in front of the car to have an air structure. But now the air structure is inside.
In the
So
when we did Hooke, you remember, Frei produced a book. I don't know how many examples of ideas in the book. Do
you remember me? There are maybe about 60 sketches in
Yeah.
how we could do it, and we have done only 2.
Got a long way to go, and so you see, that's why it's so important to encourage Frei.
It has to
Hooke
be-
and help us to
I
further this.
will say, as the engineering is still not perfect in especially in architecture, because very seldom was proved what the calculation said it is in the building, because it is so difficult to measure these stresses and forces in building. I started in my Montreal building. I put a press, a hydraulic press under the mass, and I measured the force in the mass, and we measured all cables, and we did know that our static calculation done by Fritz Leonhardt and the reality would fit together. But when it is done, so frankly spoken, I have in Germany a friend, it's Stefan Poloni, a famous engineer, and he always is accusing his friends, you are not scientific enough. You are calculating and you are hoping that your calculation is correct. But it can be only correct if you have proved the building. So this is one of those points which has to be done in the future. But in architecture, so many things has been done. When we discovered that now, after the 11th of September, that there was a mistake in this tower, and it should be not have been so early collapse or never collapse. And all these things, it's never a mistake. Of course, you have a static calculation, it's proved, it's not a mistake. But if something happening, mostly under earthquakes, or through man. Man is the biggest enemy of buildings. And we have sometimes to go other ways. And it has to be thought of. The new century is full of problems and of tasks. I am a man of the last century, mostly, I hope.
Nonsense.
I-
Absolute nonsense.
No,
I
hope to have.
You've spanned both centuries.
I hope
Right.
that I have a few years in this century, but nevertheless, it's not my century, it is your century. And this has to be done. And don't think that all is done in architecture. No. There must be a big start. So be optimistic. Do a thing. Also, you must do experiments, even also if they are dangerous. But you have to be you have to be some dust in the air. But you have to do it and to be as careful as possible.
Now look, is there a question here in this part of the room? Please. Oh, yes, right at the back there.
Can you pass the mic to them?
I think we've got one. All right.
I'm sorry. Maybe it's a strange question. I don't know if you will understand. But once I heard that there was, if you build an ant, you know, a very little ant, yeah.
What?
Una hormiga? An ant? Yeah, an ant.
Or an ant.
Yeah?
An ant. If you build an ant, you know, an animal, an ant.
Yes.
Yes, go on.
If you build it in another scale, like you try to make it like really, really big,
Yeah.
even if you use the same proportions and everything exactly, it will break. So I'm not sure, I don't know if that is true, but I was wondering if you had an experience of building a small model of some structure, and then when you make it in a larger scale in reality, if you had a similar experience of, you know, you understand?
I do. No, really.
How shall I try
to answer that
answer?
one, yeah.
Firstly, I never did were thinking to build an animal. I never did think to build a man or a plant. Even our tree structures, they are not imitation, but they are self-developing structures, and it happened that they are looking similar. Of course, there are so many books now out in the world saying Frei Otto is a man of the bionics and is looking to living nature and then is inventing structures. And this is not true. One example, I have several ones, when we have built these large roofs out of cable nets. Then biologists come to me, to Stuttgart, asking me, especially the specialists on spider webs, did ask me how they are constructed. And they hoped that with our knowledge of large buildings and of forces and shaping, we could answer their question. What I answered was, shall we not write together a book? But you must better look to your spider webs. And then they made tests of the knots and so on. And we did write the book, Nets in Nature and Techniques. But and we could do it only because we have had our knowledge taken with pure technical or architectural methods. And normally this is a way. It is very, very seldom that man is learning from living nature. Of course, you can learn from living nature, but you must be incredibly clever. I cannot direct learn from living nature. I know living nature is not imitable. What is
Imitable.
not
Yeah.
imitable. It is so complicated, and before you could imitate, you have to understand things. Until now, living nature is not understood, and it takes a very long way. Of course, with biologists, we tried to understand the living nature a little bit more, but never to use it directly in architecture, because it may be not possible. I really don't know. There are some things what you can learn, especially of heat situation and so on. But coming back to the aunt, when I was a little boy, I loved my aunts, and I really had some knowledge of their language. Yes, they can talk to each other. And the first time I heard an animal asking the other one, I have not understood what is it. It was for me similar like to know and to ask what is the main question of all intellectual animals or on man. Not to know a thing and to ask for an answer.
Okay, thank you. Yeah, that was very interesting. But I, I think that I have to make another question then. I mean, if you have had an experience of building a model in a small scale and trying to make the experiments so it will work and stand, and then if you had had the experience of when you really build it and construct it in the real scale, if it was different, like the forces and the you know what I mean?
I had the feeling on your first question that this was a real question. But I used the opportunity to talk a little. But one thing is true. If you have a surface carrying very light structure, like a balloon or a thin shell or an umbrella, if you enlarge it and it gets the same forces like a larger one, you can enlarge it just correct in size. I mean, if you have a beam of 10 centimeter thickness and you enlarge it to 1 meter, I mean in just 1 to 10 you can enlarge the umbrella also 1 to 10 because it gets the same load per square and all surfaces are also getting in the same direction, so you can do it. But then you have heavy structures, big weight on. Weight is also going apart in the third dimension. You have to be very careful, and especially if you have large spans in heavyweight structures. It means in concrete or stone or earth, and then you have to be careful in enlarging the models. But if you know the laws of modeling, it is also not a problem. You are allowed to do these models. But you should really also test it. We are making similar models, many different models, one only to look, one to test, and very seldom to so-called static test model, where we also prove what is their final limit of taking forces. I could not all show. We have done, at least in my office, and besides are standing now around 200 models. So there's many, many different modeling surfaces. And always it is a problem to make them in such a way that they can be used also as a tool for the engineers, but it needs clever engineers with modern methods of mathematics. But before 1968, I will say it, the engineers had no possibilities to calculate those of my first building. And I said to them, if you can't calculate these structures, but I will build them and I will prove them, because I had the modeling statics. And it was Frei Leonhardt. He put in the school of Stuttgart 2 new institute, one for modeling statics, model statics. I mean, with models to prove the building. And the other institute was MICE for lightweight carrying surfaces. And both institutions has had good success. And it was then Ted Happold bringing the background of the Stuttgart school to England when he founded the new school at the university in Bath. So there was a direct connection between Stuttgart and Bath, Stuttgart and London. I by myself was asked by OVL, I think it was also 67 or 68, and I did install the Model Institute as of the Arabs, and I leaded it, I think, 3 years. Later on it was Michael Dixon on this job. It was a long answer, I hope it was one.
I had one over there.
Behind us. Yes, we see him, but I'm just wondering if you've got a... Oh, here you are, yes, here you go.
Okay, my question concerns the aesthetic side of your work. The question is, do aesthetic considerations come in as an element besides the structural solution, or do you believe that the aesthetically pleasing experience of your work is going to be automatically derived by from the genius of the structural solution?
It was my friend Rolf Gutbrod. He said, when we are working on a project very careful, then maybe someone in the sky gives us as a result the beauty. I still think it is not possible in a direct way to plan the aesthetics, especially in a new field, because aesthetics is a kind of common sense. I still remember some of my buildings which are now in all books as a symbol of new aesthetics. We found when we get them out of our modeling, they are ugly. And then after a while, people start to understand, discovering the special quality, and then it can happen, if you are happy, that people are saying your buildings are beautiful. People are saying it, and you can't do it directly beautiful. Only it is possible for buildings of methods which are very old. If you want today to design a Greek temple, then everyone does know how a Greek temple has to see. I has had once a very strange situation. I was a student being in New York, and the famous building of Picasso, the Guernica, was in New York in the Museum of Modern Art. I did not know it, but I did know the building, as the painting. But I did not know that when I go up the stair that I am in front of the Guernica. And I did know, of course, that Picasso has painted it to show to the world the ugliness of the world, not to make a picture which is looking beautiful. But in front of the Guernica were standing two young people. Maybe they have been in love to each other, and they did talk, how beautiful is this painting. Now the Guernica, of course, it is a symbol of the aesthetics of the 20th. So I don't know if this is an answer or not. I believe that if you are working on new fields, you have no line which can tell you what is beautiful or not. For me, it's more important to be good, good in a human sense. To make a good building is for me much more important as to make a beautiful one. But when you have made a good building and it's then also beautiful, that is a gift. But I will add, what I fear of today, especially working with computers, with special programs, and all is looking so perfect without any control. I mean, now some of your generation are only interested to make beautiful buildings instead of to making good ones. And I please you, at first make good buildings in a human sense that people can live in it or enjoy it. And then let's be a gift to get the beauty. That was another question.
What? Sorry, yes. It's an extension of the previous question. I speak loudly.
Thank you. I wanted to extend the previous question. When you were showing the project with the Stuttgart railway, big covering, I actually thought it was extremely beautiful. When you showed the final solution with the model, I was quite moved. I thought it was an extremely beautiful space. And I was wondering if you can explain maybe the process whereby one comes to a discovery. You mentioned a very beautiful phrase that while you were designing, you tried not to modify too much in the process of trying to discover what the solution might be. You were talking about that opening and the single arch becoming a column. I'm interested in this process of not trying to design, but allowing things to happen, if you like, as a discovery, and what that feels like and what it's like.
But I do know what I can answer here. I have the feeling I have answered your question before. One thing I said, when we make experiments, we always try not too much to interfere. I mean, really discover these self-making processes in non-living nature. These are optimizing processes. There are some shapes which can't be done, and some are always coming out just to know better the nature and not much to deform. It is a question also of the feeling of stability. When an architect starts now, sometimes it's necessary, then I believe it's correct, then to make a huge tower which is leaning over. And if people always had a feeling that the building will collapse, and so you get a feeling of unsureness. Of course, if you see such a building, and of course your eyes are always taken by the shape of the building. And some architects warn that their buildings should be seen as a special event. I think not too much deform nature, because also techniques, also architecture, all what man is doing is a part of nature. Techniques are a part of nature made by man. Some of this artificial nature is in the scope of nature, and some is artificial, like all art is artificial, but in the just playing between natural shapes and complete artificial shapes, there is a very strange and peculiar area. And I think there we have been very careful. An artist and a painter can easily paint anything. An architect has a higher responsibility to people, and he should be careful not just to make, to be published just to make a crazy looking building. Yes, no, if there are, but I have the feeling that not I am tired of it.
We've got a few minutes more, haven't we? Just a few minutes more, because, you know, when you get a thing like this happening, it is, as I say, a historic event, and you expect that. So the next...
Yes. I was just wondering, looking at your work, the way you move through your process of these layers of models and trying to get the behaviors, the data out of the model. And now with this new tool that we all have, the computer, have you been able to revisit some of your older work or to use these programs with some of your newer structures somehow? To go back and look at these behaviors, or to maybe to investigate a more complex pattern that you weren't able to see before?
I have not really understood this question.
I think the question is that, I mean, really, have the computers given you the possibility of investigating things that you've done in the past in a different way?
Yeah.
That's really it. Have they helped at all? Have you used them in that way? That's the...
Of course, I'm convinced that for the young generation of architects, the computer is a very big help. Now, I could not use the computer when I started. Now I am using it, but not by myself, for analyzing the design.
Mm-hmm.
But as I remember, we never have done analysis of an older building, which I have done. I mean, to look once more back to the methods of design.
You're analyzing the future design.
Of course, design is always going into the future. And we started to use the computer very early in the Montreal building, but only to show, it was quite funny. The first use of computers was the following. It was a world exhibition in Montreal, and the German government had a special man and commission, and the commission said we must show the first computer in the world invented by Konrad Zuse, and we should put the computer in the pavilion as an object for the public to look at it. But then we had an idea, can we not use the computer to make the design of our building? We had only the model, and then we measured the model and put this into the computer, and then the computer did draw on the world exhibitions the sections of, but the computer drawing and the drawing machine has had some problems, and they start quite slow, then it makes a mistake, coming exactly back to the point, makes another mistake, but finally it was ready. This was our first computer drawing which we have had. Later on at the Munich things, all things we had that should be our friends at the university in Stuttgart, especially around a man who had also a professorship in London, John Argyros, one of the inventors of the finite element. And formulas of 3,000 to 5,000 unknowns had to be taken in. But biggest problem was they had to be stamped on hollow cards, on cards like this with holes in. And one day during the night it has to be brought from one institution to the other. It was an accident and all hollow cards were sidewards of the Autobahn. And there was a problem for us because we lost 3 weeks on the progress of the design. And the leaders of the Olympics did not like it.
We still lose things in computers too.
Yeah.
Look, I think we should. There's one more question. Shall we take one more and then we'll wrap it up?
In several publications and other occasions, you have pointed towards the fact that in non-living nature, including human architects, imperfections and irregularities in the organization of a material system can be structurally beneficial. Could you perhaps elaborate on that?
Yes, and of course, very well known it is in techniques. If you have iron, clear iron, it is very soft. And if some imperfections are in, maybe the carbon atoms, then it is not so easy to have a tearing. The same happened with diamonds. Very good diamonds, I mean for aesthetics. It is very breakable. But diamonds for industries, they have to have mystics. They are not as good, but are better, because, yes, they are not as good for looking at. They are hard, but very sensitive if you put the glass. And the same happened with many things. We discovered, my first collapse I have shown you as a building was that we used a very, very good made canvas and machine proofed. Before it was all in cotton fiber. Yeah? All tents before 1955 has been in cotton. Why we had this tearing? And you know it when you buy a woven material. You know the best woven material, the waiter can put a little section in and just pull it. But if you have a potato sack, yeah, very, very badly done, just only for potatoes, you can't tear it. Yeah? And in living nature it's the same. And the main reason is in living nature, these cells, they are all little water sacs with fibers. Fibers are making the skin of the cell. But the cells are put together similar like foam. And the one secret of the foam is that each bubble is different like the other one. With foam you can never make a crystal because the law of the foam is that all walls are under 120 degrees and in the corner 4 bubbles exactly with 108.5 degrees are connecting, but between there are little curves and these cannot put together. It means in living nature every object is different, even when the objects have the same genetic code. One leaf of a tree is different like another one. and it can't be that they are the same. And the connection. And this may be one of the reasons that some wooden materials, like fingernails and skins, and are very good. Our skin is very sensitive for very sharp instruments, but not so much against tearing. It is very difficult to tear, to pull it apart. So I think that the contradiction against the society of elements which are in right angles, in living nature you have sometimes right angles, but never 100% perfect, and very seldom. The 120 degrees or 188 degree angle is much more common in living nature. I hope it was an answer.
Before you go, our president, Eva Dürikner, has a presentation to make. Eva Dürikner.
I'm definitely not going to make a speech because, Frei, you made me absolutely speechless. So everybody who wants to go home would be very pleased that I'm not going to say anything. But I think that we have all witnessed how you made another dimension to basic expressions which we use in everyday life, like ideas, experiment, invention, and now, I was going to say that it was a marriage of architecture and structure engineering, but it would be a harem, if I am to describe the relationship of everything which you described today. And I'm just going to tell you a little story. When we first met prior to the lecture, so Richard asked me, have you met before? And the answer is that we seldom have met because I have been to Frei's lectures before. But my first encounter with Frei was in 1965, and that is the proof of it, this little book. There was a Congress of Architects in 1965, and I, as a student, believe it or not, once I was a student as well, without gray hair, which is slightly covered or camouflaged, but and because I won one of the prizes for a design of School of Architecture as an honor, at the dinner I was seated next to Phoenix Candela. And he was the smartest man in the audience, wearing a white suit, and all the girls were going around him and asking for signature. Well, in order to impress him, I didn't know what else to ask him, so I said in my miserable English that time, if he could suggest one book on an architect, on architecture, which I should buy, because I had no money coming from Czechoslovakia. I think that I had probably the equivalent of £2.50 in my pocket. So it was just enough for one book. And he said to me that if there is only one book which you should buy and which you should keep on your bookshelf, that is the book. That is the book which has been with me since 1965, which has been lost, borrowed by all the structure engineers we have ever worked with, copied endlessly, and I can show it to you. I will not lend it to anybody. But if you imagine that it's almost 40 years ago when this man who has given us this wonderful, unforgettable lecture has been famous, and he is famous still. And I think, that is an entire proof to be ahead of one's time. So, Frei, thank you very much. Now, I have got one duty to do, which is to read, if I can read it, what Moisten has asked me to tell you before I hand you this honorary diploma. And Moysen says, for your contribution to architectural innovation and your great mastery of architecture, from imaginative handling of the smallest of joints to the largest of buildings, the Architectural Association has great pleasure to awarding you to honorary diploma. Thank you.